Hello, everybody, and welcome to Documentation Not Included, a tech industry podcast presented by DNIStream, the live knowledge repository for software professionals. It's Thursday at 7 o'clock BST. Are we still on BST? We're on GMT now. No, we're on BST every week. One of us gets it wrong. And we are live on twitch.tv/DNIStream. I'm Chris, and unfortunately Josie is ill. Hopefully not too serious. From what she's described, it sounds a little bit ominous, considering the current situation, but hopefully get well soon, Josie, and I'm sure all of our listeners are saying the same. I am, however, joined by Zane. Zane has been on the show before, so please do introduce yourself, Zane. Tell everybody who you are and what you do.
I'm Zane Daniel, and I am a data strategy consultant. So I focus on data strategy and implementations of data.
Good stuff. So, as always, a big hello to everybody in Twitch chat. There's already been a few people chatting. I like to see that before the show, as always. Sometimes I was doing a stream yesterday and I had pretty much no one talk to me the entire 4 hours I was streaming, but it's really nice when we do get an audience. So please do get involved. We are live and we do field questions on the show. So before we get going, let's get our icebreaker question out the way. So I had something in mind when I thought of this one today, but it's a bit weird, but I'm going to let you run with it. What is your favourite 1 or 2 meters squared on the planet?
1 or 2 meters squared?
Yeah, so, what is your favourite small space on the planet?
I don't know, it would probably be my room, right?
So that's, a lot of programmers would say that, and that's would be my, probably if I was asked the question, stock answer. But I had 2 others. Go on, have you got anything else? Or
give me an example of what you had in mind.
So 2 others. One is my bike. Whenever I'm on my cycle, I absolutely love it because I can go anywhere. I can go anywhere in the world. It's not a motorcycle; it's a push bike. But I'm really keen. In the summer. Unfortunately, it's been the loveliest summer ever, and we're not allowed to go outside. And I'd be out on my bike at this time of year. But other than that, there's a little rock up in Scotland in a little place, and I think I've probably mentioned it on the podcast before. Up in Scotland, a little place called Port Logan that I sit on. When I was a kid, I used to sit on it and watch the sun go down, or sit on it and wait for my dad to come back from his days fishing, because it was kind of on a rock looking out into the sea, into the Irish Sea, I think. Yeah, it will have been the Irish Sea. And just a lovely, really quiet. There's no sound anywhere. It's just a lovely experience being there. They're the kind of things I was looking for.
I can't. Well, I would say my room. Bike. I do like my bike, but there's just so many things, right? The bike and then the computer as well. The 2 meter square where a good computer with the screen, I guess. So it's just hard to choose.
Yeah, I think the thing is, I get so much joy out of this 2 meter squared that I sit in because I do everything on my computer. I do a whole manner of things, and I'm never bored when I'm at it. Yeah. Very occasionally, I'll be like, all right, I've had enough. I'm closing down, and I don't. But most of the time, I have to pull myself away from it and go and do real life things. But yeah, it's a hard one. Anyway, so let's move on to the topic today. We've got Zane back to talk about artificial intelligence again, because last time we kind of had a primer on it. We talked about it in general. We went into in a few little bits of detail around some subjects, but we wanted to have Zane back to talk about the limitations of artificial intelligence, what it is, I suppose, not capable of, where its weaknesses are. So let's get going. I think we can start off with what are the limitations of AI? I mean, we talked about them a little bit last time.
So yeah, actually, let's talk about the limitations of say facial recognition. If I can, I'll start with the example of the example of recognition of cats and dogs pictures. So we have seen that that's very easy to do, and we can recognize a cat and a dog and distinguish that very easily. The next part of recognition is recognizing the breed and recognizing the different types of within the breeds and all the different within all the different species you can think of dogs and cats. And obviously each one will have slightly different facial features and or body features. Cats will have a different all sorts of different you could say patterns on their body. The thing is that would be the next step of saying, okay, now we can recognize cats and dogs. Now we want to recognize the breeds and distinguish them and say, you know what, where are we likely to find this cats and this particular cat? So the thing is that what happens is when normally this all happens with the neural network. So what you do is you have a neural network and you're trying to distinguish between only two items, which is either it's a cat or a dog.
Mm-hmm.
So for a neural network, that is a very, very easy job to distinguish between two classes, which is one class is dog, one class is cat.
But surely some dogs, cats would never really be mistook for dogs, but some dogs could be mistook for cats.
But the thing is that because when you're training the AI model, you're giving it so many pictures, and it will see that the general shape of a dog and the facial recognition and facial features as well as the body features, it will know that this label of a dog, we know that this is a dog. It'll get it like 99% correct.
Okay, all right, fair enough.
Even it might get actually one or two wrong depending on what sort of data you've provided. It might actually happen. We don't expect it to be 100% right anyway. But the thing is that, and that's the easy part. It becomes trickier as soon as you are increasing the number of classes it has to distinguish between. So then, say you are now saying, oh, we have, say, 10 breeds. We are going to give it 10 breeds, and we want to distinguish which cat is according to which breed. That becomes very difficult because now it has to create sort of a mapping of 10 different features based on the sort of understanding it can get. And the way we would do that, we would add more layers. So, for example, let me just talk about what it means to add layers. Last time, if you were here, what I mentioned is that when you are recognizing the letter A, what we do is the way we recognize is that we have letter A, and then whenever another letter A appears, we do what's called one pixel minus the other. It's normally called a dice coefficient. So we do that, and then we get a very big value when two A's are matching. So two pictures of A are matching. Now the thing is that that's not exactly how it happens, because that's not it's not possible. What actually happens is we take the image of A, we break it down into smaller pictures, and then we break down the incoming picture into smaller pictures as well, and then we do the comparison on the smaller pictures. Or in fact, we break down the smaller pictures into further smaller pictures, and the comparison is done on the smaller, the smaller pictures of the smaller pictures.
Children.
So the chunk of the chunk, yeah. So that's the sort of thing the comparison is done with. Now, what happens is when you break down a picture into a chunk, and then break down that chunk into another chunk. So, for example, let me give an example. The best way is, say we have the letter 9, right? We have the letter 9, which has a bit of a shape of O at the top and a straight line at the bottom. So we can say that, we can divide the letter 9 into two shapes. There's the O and there's a 1 sort of thing, or like a straight line at the bottom. And if we give it we break it down into chunks, we know that this is one shape and this is another shape, and this makes up, and the position of the shapes makes up the whole shape. And that sort of thing is broken down into, say, one layer of neural network will recognize the one shape of an O, and another layer will recognize the shape of the line. And then it will, what would happen is that as the picture is propagating through the neural network, it will light up this particular shape and then the other shape, and then say that these two shapes have the link to number 9. So this is how it normally works.
Yep.
So what we do is we say that one layer, we're supposing that one layer is going to break down the image into one particular features. So for a cat, it could be, say, the whiskers, and one layer would be it will recognize the whiskers, and another layer would recognize the eyes, and it will basically sort of create sort of mappings of what that actual face or what that actually looks like.
Yep.
So and it becomes more and more difficult because, as you mentioned, that some dogs may actually look like cats. Now that's when it becomes more difficult, because some cats may look like other breeds of cats, right? So they could be very similar. That is where it starts to get wrong. It fails. And that's one issue. Now the thing is that the reason why normal people like us may not have noticed it is because these sort of problems are only tackled by big companies like Google and Microsoft, and they have huge data centers, huge GPU, unlimited GPU almost, and they have the world of computers to train the best neural networks and the models they can do. And they can do that regularly, and they can keep on updating by adding more pictures and recognizing and adding more layers, and then keep on doing that. Now that's something that's possible, and they can minimize the problem of that scale issue.
Yep.
And they can do that. However, as normal people who are doing research, or who might have, for us, if we are trying to build it ourselves, we would need to spend a lot of money to do that, because we would have to run on big GPUs or buy GPUs and then train for days, and then it might not be right. Then we have to do another training.
Yep.
So that's basically one issue. Now the thing is that one of the ways that Google would do that, or the way you make it simpler, is you break it down. You basically say one neural network will have that problem of distinguish between cats and dogs. Then, what we first do is we take a picture, and then we feed it into that cats and dogs neural network. It will say it's a cat. Then we take that cat's picture and put it into another neural network, which basically distinguishes which breed. Say we first only distinguish a group of 10, and then it say, okay, fine, it seems to be within that number 2, and then we take that picture again, and then we put it into another neural network, and we say, okay, now let's try to distinguish it as much as possible. So that's the sort of way of dealing with scale.
Okay.
Now, when it comes to facial recognition, here's the hard part, and here's why Facebook gets it, right, and people are like, Facebook gets it, pretty much 99.99% correct. Whenever I upload a picture, it recognizes my image, it recognizes my friend's image, and it basically labels everyone's image correctly all the time. How does it do that? Now, the thing is, the reason why it works so well is that Facebook will basically limit the number of classes it has to distinguish. So, for example, it knows that in that picture there are 10 faces, and you have about 100, and you might have, say, 400 friends, but you interact with about, say, 20 friends on a regular basis. So it will basically limit the problem into 20 friends and distinguish the faces against 20 different faces. And that's a much easier problem to solve.
It will already, for each of those faces, though, it will already have a output, a neural network, a result. They'll already know what that face looks like. The AI will already know. So they don't have to do that work. They just have to run the output of your friends' faces on your images that you upload. So I imagine it's quite a quick process either way.
So for them, it's easier, but the reason why it is quick because they have already done that. But one of the reasons why it's quicker is because they're limiting the problem. So what I was going to say next is that, say, when people think, because Facebook can do it so well, I've seen it myself, facial recognition works, roll it out to for surveillance. Now the issue is, here's the issue: when you roll it out, and as soon as you scale to tens of thousands or even 1,000, and you want to distinguish one face against 1,000 faces, and then you want to get it right, it's very difficult, because now you are increasing the number of classes. Your neural network, whatever it was trained on, it probably was not Google's, and it probably was not Facebook's if you are rolling out a surveillance technology. Now that's where it fails, and that's where we see headlines such as someone was caught due to AI surveillance technology, but that person was not the right person, and it was someone else. And then we read articles like the accuracy needs to be 99.99% or higher, and that's true. And also it's because of how you the thing is that the whole way how a neural network works, it fails miserably when it needs to distinguish between more than 1,000 classes. It just fails because it's already very heavy in what it's doing, and we simply, even if we try to make it heavier, and give more GPU to it, it's not gonna work.
Yeah.
So you have to solve it in a different way. So for one of the things that some companies do, for example, one company was the Clearview, was basically what they were doing is breaking down facial recognition facial features, and then breaking them down into a way where we can decrease the number of classes, so we have a much higher sort of facial recognition.
So they're basically saying that there are this many types of noses, there are these many types of mouths, there are these many types of eyebrows, etc. And then they're using the data from that output to create closer matches with individual faces, section by section. Is that right?
So that, and also basically putting some sort of like putting dots on the face. So, and then saying not dots on the face, but basically saying where the eyes are and where the nose is, and the relationship of those. So trying to reduce the problem of not giving more than 1,000 classes to a neural network. Now, and that's still a very difficult problem to do. Now, the thing is that in order for it to work 100%, or not 100%, so let's say in order for it to work more than 99, or really accurately, what you have to do is you have to give it a lot of pictures for everyone. Okay. So for example, for cats and dogs, we give it 10,000 pictures, so 5,000 for each, cats and dogs. Now imagine giving 5,000 pictures of each person, and then giving it the highest quality of that person. No, who's gonna possibly do that? Obviously, other than people are uploading their pictures onto Facebook, and it's adding up, and people are also Amazon Prime rolled out this photo photo like digital library, so you can upload your pictures and unlimited pictures, and you can use that service like a Dropbox thing. So that's also, those pictures can be used because you have, say, 5,000 pictures of each person, of their different facial angles and different lights, and then you have that sort of map. So, and then here's another issue with facial recognition technology, which is that which Apple understood really well, and they basically have this infrared thing, because the thing is that can you still hear me?
Yeah. Okay,
cool. It's just that the image was there. I was wondering whether it disconnected or not.
No. I'm engrossed. That's all. It's as I said before, I'm not that knowledgeable on AI, so what I interject isn't going to be particularly useful. So I'm biding my time here. I'm seeing. I'm trying to take as much information as possible.
Okay, cool. So basically, the other problem with at least with facial recognition is that darker faces or even lighter faces, but with say not good lighting, basically cannot be recognized. So this is one of the issues that happened ages ago, which was that people thought that AI is racist and it
Right.
was not recognizing correctly. Now it's just one of those things that it's just a bad technology due to the fact that it simply cannot work solely on a light.
Okay. Hello.
Hello.
You are popping up with connection interrupted, but you're not actually being interrupted. I can still hear you clearly. Oh, I think we may
Okay,
be
cool.
losing
Fine. I
zone.
thought.
No, it seems okay. Don't worry at the moment.
Okay, cool. Okay, so what Apple have done is basically use infrared, and what infrared does is basically creates, projects infrared onto the person's face, and then it reads back, and that is much more accurate, and it simply works for every single face.
Right. Okay.
Even to the point that you can wear glasses, and you can wear two glasses. Sometimes I wear, extra pair for when I'm doing my, programming stuff.
Okay.
So I wear two glasses, and it still works.
So infrared, is that still AI though? Is that still classed as AI? Because the infrared is all. I'm assuming that's scanning the face rather than. I suppose that's what AI is doing, isn't it? Scanning it and storing images and analyzing images.
Basically, what infrared is doing is basically providing the AI model with another input,
Right.
and saying, okay, this is the picture with the face with natural light, or with the low light or whatever, and this is what the face looks like, and then the person has provided the face image once, but then he also provides the infrared, and the infrared basically is sort of, because it's two inputs to the AI, it's much more accurate, and it's in fact much, you could say, because it's distinguishing only one person against everyone else. It knows that if it's someone else, then don't recognize it. It's only one person. It just works really well. So
it's interesting. That's certainly interesting. So when you say it's giving them an additional input, is that just another channel? So it's also using the plane image as well as the infrared image. So it's doing, when the infrared image is being scanned, is it scanning the infrared image in the same way that it would scan the standard image? And all it's doing is overlaying the infrared information.
So it's doing a bit of a 3D thing as well, because if the infrared camera is slightly further away from the normal light camera, and it's basically doing that, where it's combining the two things, and then it's saying that this person seems to be, yes, this is the right person.
Right. Okay.
Because what it's trying to do is that it's trying to reduce the likelihood of someone who looks like you, who are actually are picture perfect. You basically print a perfect picture, say 600 DPI, and then you basically stick it in front of the camera. Then obviously it will recognize it because it's only a single camera, right? But because it's two things, it's camera and infrared. First, it's giving you a 3D slightly, and so it knows that this is basically a real. It's not a picture anymore.
Right.
So and the second thing it does is it's going to say that not even your identical twin will be able to, unless you're a child, and then because they are very, very similar to each other, it's difficult. But yeah, if the idea is that because you have you will be different to your identical twin, there's no way it's gonna try and you will be able to access the phone, and that's quite clever.
That is very clever, because that was my next question about identical twins that look the same to us, and they can fool quite often other humans.
Yeah.
So, can you? I know you just did, but can you explain maybe in a bit more detail how it distinguishes between someone who looks identical to somebody else? Because to me, if I have an identical twin, I might look like them if I have if I'm in a particular facial expression. If you know what I mean.
Yeah, yeah. So the thing is that it's first of all, what it does is it's going to build up some sort of a map of your face. But the other thing is that because it knows that this is the sort of face, what it looks like, I'm not sure of how it will actually distinguish in the if it's say a child, because a child is just too similar. It's too difficult. But for someone who's grown up, even if you have one or two angles, but because you have so many other angles which are different, then it will know that this is the sort of person we scanned first.
Okay.
And also it can fail. Whereas in it, if for example, if it sees that all of a sudden, say you shave your beard, then it will simply fail because it's.
I was going to say, if I have an accident and I get a scar on my face,
then
I'm going to be quite different. And let's say in the future where we're all using our faces to log on to things, well, I know we do it now, but let's say that becomes a standard. What happens when you have an accident and this happens, or you decide, right, I want to shave my beard off, or you get significantly older and the AI algorithm still doesn't recognize the additional wrinkles that you've got? I mean, would they just have to retrain the AI in that instance?
So it's the interesting thing is that it doesn't. It's quite interesting, at least for Apple, at least for that Face ID feature. It's very limited because it's only doing for one person, and it knows that this is the person who is using the phone. And another thing is that on top of that is because as you're constantly logging in, it's constantly scanning your face. So it constantly knows the changes that your face will go through.
I think I'm thinking of people who wouldn't log on to a system for a long time. For example, there are some accounts that I have that I haven't logged onto for years, but I may want to log onto them sometime in the future. There's been a few accounts this year I've logged onto that I didn't think I would, but I'm back on. So in that instance, they haven't seen me for 5 years, and then suddenly they get a new image of me with this big bushy beard and additional, wrinkles between my eyes. They wouldn't recognize me, surely.
So the thing is that here's quite interesting. Here's something quite interesting. Google and Apple or Microsoft or Amazon or Facebook do not provide a facial recognition API such that, like we have the login system authentication, where we can say, they provide an API where we can actually log in to Microsoft, and then it checks that, this person is correctly logged in. Then it sends a response back, and that this person is correctly logged in. They do not do that with an image. They do not do where it's, there are cameras available on Amazon, which basically have this Windows Hello thing. So you could actually use those cameras to build up an image with a infrared map. The thing is that still none of these big companies offer this feature where you can say, if you give us images of this person, say 5 images, and have this person, look like, do a round face and then turn this way, turn that way, and so on. And then we will basically provide a login system where every time they need to log in, then they basically show their face to the camera, to this particular camera that you have bought. Then they will log in. There's no feature.
Well, I could see if are you saying they would need a special camera to do that?
Yeah. So at least the camera is available. Say, for example, on Amazon, it's a Windows Hello special camera, which is a camera with an infrared built in.
So I can see 2 problems with that. One, the barrier to entry there. Is that people need to have a very special camera for it. And secondly, even if they had a special camera, surely they could hold up an image of somebody else, of the person they want to log on to in front of the camera, or they can somehow project, and I'm sure there's some security built into it, but somehow they could stream an image to the service. If they had a log-on service via their API that allowed them to essentially send an image from the camera to the API, someone will be able to spoof that and send an image of somebody from Facebook and say, I want to log into their Facebook account. I've got this picture of them. There you go.
So that's what I'm saying, that because there are two cameras, there's one normal camera and there's one infrared, it creates a 3D map.
Oh, right.
It's gonna fail. In fact, what's interesting is that someone actually, well, they were testing when Face ID newly came out. They basically 3D printed a whole like a face of someone with the exact colors and all the features perfectly. In fact, probably not 3D printed, or probably carved out of some sort of clay.
Yep.
And they tried to basically recognize, and it just did not recognize. And the thing is that why it did not do that, that's something. It's a good feature, but it's something where we can see why it requires, you could say, further programming in that sense. But we definitely know it fails at an image, because an image is basically a 2D image, and the cameras will know straight away that they're looking at a plane.
Okay, so that's just my ignorance there. I don't know anything about this world, so yeah, I assumed that it was just an image, a camera that took an image of some description. But if it takes a 3D image of some description, then that makes more sense. So we've talked a little bit there about how or the limitations of AI being used for facial recognition. So can we talk? Have we got anything to talk about outside of facial recognition? The AI or rather AI's general limitations.
So AI's general limitations are, let's talk about the self-driving cars. So self-driving cars, basically, they're the companies who make them, all the big companies, Uber, Tesla, Volvo, all the big companies that are in this particular game right now. They have the same problem, which is that we train AI, we give it a data, and it learns, and that's all it knows.
Yeah.
So, and it just does not generalize enough for it to know this is what it might be in a different scenario. So they have to give it every single scenario.
And they have to give it a lot of sensors as well to be able to
gather. Give it a lot of sensors. Now that's another limitation currently, which is that it's basically it just does not generalize enough. And the reason is that it's not. It's basically the way it's coded, the way that it does what it's supposed to do. It recognizes whatever you give it. It knows from the data you've given it that this particular feature is. It will know that particular feature, and that's it. It will not generalize to another feature, and that's one of the you could say the bane of the problem of the companies that are creating self-driving cars.
Well, surely in a self-driving car scenario, the car only has so much processing power that can be built into it. It doesn't have a server farm built into it. It doesn't have. You can't rely on it having access to the internet and having access to server farms via Wi-Fi or whatever, or satellites, etc. So it has limitations in terms of its hardware and its internal capacity as well. It can't go off and run neural networks within its own CPU or GPU, can it? I mean, it can to an extent, but not. It can't process tens of thousands of images, or the amount of data that it needs to process every millisecond for it to respond to, someone walking in front of it. Or I mean, that's different, isn't it?
It does that. However, what it doesn't do is, for example, it knows. So when you give it when you give it features, say we have given a feature, we have given images of cats and dogs, and we given it 100,000 images now, and the neural network recognizes it perfectly, and then it basically takes that, and then we basically take that script, and we optimize it so we know that it works. It works ridiculously fast. We start using C++ to do the inferences, so that it basically spits out the inference at a millisecond, a split second, as quickly as we want. We can do that, and then we basically throw millions of pictures, and then it basically throws back millions of labels. It can do that, and the reason is that once it's trained, because there are two bits of it. The training itself requires a lot of GPUs and a lot of processing power, and a lot of time.
So that's done off. That's not done on the vehicle. That's done in said server farms, and that the output of that information, that information gathering exercise, is programmed, or rather provided to the car, so the car can process on it.
New instructions or something like that.
Yeah.
And so the thing is that that's done offline, say on a Google GCP or AWS, whatever, Azure, their clouds, or there are other sort of facilities out there which do training of they do high performance computing, but much cheaply than the big players. So a company may go to them for training, and may say, okay, we want to take your GPUs and we want to train our neural networks, and then we take the output and put it into the car. The car, all its processor is supposed to do is that the processor is powerful enough to, and it's custom made, so it's bespoke. All it's supposed to do is all the sensor it has. It will basically read all the signals it can get and process them at a split second, and then pass the instructions to whatever, brake or whatnot.
Yep, it'll aggregate the data, and it'll also speak to roadside devices as well, called edge devices and IoT stuff. So
I don't think there are any. I don't think it's speaking to any edge devices.
Well, it is, because I've actually done work specifically on edge device processing of information to control things like signals based on car. It's not quite self-driving car stuff, as in sending no, actually, you know what? I'm lying. It actually was sending signals to the cars, and it's cutting edge stuff. And the sensors were set up around a city, and the sensors essentially gathered data. The edge devices, i.e. the roadside boxes, were processing the information, and then they were sending the information to the car and telling the car, right, there is 0.6 of a second, in 0.6 of a second you're going to hit this obstacle, this vulnerable road user, or whatever it is, and then the car would initiate a brake. So they kind of work together, but that isn't really AI. That's just huge amounts of data being processed and aggregated, by edge devices, and sending them to the car, and then it's up to the car what it wants to do. It uses the AI within it and uses that input as an additional piece of information to actually make a decision.
So the thing is that that's probably one of the companies, but other companies are not doing that.
No. So, I unfortunately I'm under NDA for that kind of stuff, but I can't talk about it specifically.
Other companies are basically, what they're doing is they're saying, because you can't actually, if you're relying on edge devices, then you can't actually have edge devices planted everywhere. And,
no, this is talking about high volume cities, really high volume, massive mega cities, that kind of thing.
So it's basically within city. Yeah. So the thing is that what's interesting is that because that technology is great. It basically it reduces the errors that can happen due to AI in the car. And I think the other issue is that because there are other companies out there who are making self-driving cars totally independently, not sharing code, not sharing data, and also not sharing any algorithms, I think there might be an issue with in the future that, okay, you know what, the government might want them to comply and say, well, for the safety of all citizens and everyone, we need to have that in place where you share the data, or you share the algorithm, or you do certain things in this way, such that everyone benefits if you are, if we want self-driving cars technology to really take off.
Yeah, absolutely. Yeah, I'm sure that will happen. I'm pretty sure.
Yeah. So that makes sense. The other thing is that one of the things one of the things I did see about is the some sort of a new internet coming on. We're using the satellites. So
Okay.
Tesla is actually SpaceX is actually launching satellites which basically power internet down directly. So it might be.
What does that
It,
mean? They power.
it's basically a new sort of way of delivering internet other than the mobile technologies we have currently.
Okay, well, we
So
already have satellites that deliver internet to remote, deliver high-speed internet to remote locations.
yeah, but
That's
this
been
is for
they've been around for a while. Even
general purpose.
yeah, even general purpose for hope. Because about 4 or 5 years ago, one of my contractor friends he moved into a remote location. He got he bought an my lord, my words. He subscribed to an ISP that provided remote, like SIM cards or something, some kind of remote satellite thing, and he got a fairly decent speed from it. It wasn't as good as fiber, but it was better than what he could get wired to his home.
No, so that's fine, but there's something new coming on, which is extremely high speed and something that basically is internet powered through satellites.
So
So
Volshrat's just said in chat, is this referring to Starlink satellites?
Starlink satellites, but
Okay.
I think there are other companies which are working together. For example, I think Apple is also working on this in association with companies. So I think some big companies, because they obviously recognize that it would be beneficial for all of them that everyone uses internet which is high powered, then there seems to be something which is new. And I think even self-driving cars will be using that sort of technology to be always connected no matter where you are.
Yeah.
So you're not relying on.
So it's also worth mentioning as well that it's not just self-driving cars that are going to have AI in them. It's dashboard, normal cars that just have CPUs built into them that can take commands again and can help and aid the driver. Specifically, the stuff that I was talking about was sending signals to dash units in self-driving and in standard vehicles. Well, I say standard; they've got computers in them, so they're not. I suppose they're standard these days, but they are. They've got AI within them that controls things, and it's basically for vulnerable road users. So if somebody is on a cycle or a pedestrian walks into the road, the sensors detect things and then, sends a signal to the car that's turning around the corner that's going to hit them in a second or 2 seconds time to say stop, and it will stop. And that worries me a little bit, but at the same time, it obviously reduces fatalities and accidents as well. I think they've already done studies on that kind of thing.
Yeah. That is quite interesting, yeah.
Yeah. Okay, so we are actually just looking at the time there. We are coming up to the end of our show anyway. Have you got any closing comments? Is there anything that again, I'm sure there's plenty of things you've missed out that you haven't been able to talk about. We've talked about a little bit about AI at scale as well. How it is limited when you try and scale it up, when you try and give it more information than it can currently handle. More than what you said about more than 1,000 different types of class that it can send into it. And is that a hard limit at the moment, or is that because of hardware?
No, it's not hard. It's not a hardware limit. It's more like a software limit.
Right. So it's the programming within the neural networks.
Basically, the actual programming, or how do we program AI or neural networks, or better some sort of the better technology than neural networks, which processes more. You could say more classes. So that's purely a software limit, purely limited by the research and how, if we can think of a better algorithm, then we can basically overcome that.
I was working with some very clever people, clever academics that were working in machine learning and AI. I may have mentioned them last time we were talking, and they were working on ridiculously, I mean, way above my head, absolutely way above my head. I know how to put, enterprise solutions together, but when it comes to the stuff that they were doing, they were creating linear models, and they were going into all kinds of mathematics that I had no idea about, and they were using functional programming to make it quicker, to process more data, and to be able to so I said process data quicker, because the models that we use, the programming languages rather that we use, are quite literally too slow for the serious amount of data that they had to process to be able to get to the end result that they needed to get to, and that was fairly small scale really for what we're talking about here, but it was still really interesting that they were using machine learning and AI to do that. Again, way above my head, and well out of NDAs, well under NDA as well. So I can't, again, even if I knew more about it, I couldn't talk about it in more detail.
Yeah.
Anyway, so yes, I think we'll close the show then.
So in terms of, I could talk about, I'll give a quick definition of what learning is, or machine learning.
Yeah, okay.
So it's basically from a book, which is quite a nice book on artificial intelligence. It's Artificial Intelligence, A Modern Approach.
Okay.
The third edition by Stuart Russell and Peter Norvig. It's basically giving a definition of an agent is learning if it improves its performance on future tasks after making observations about the world. Learning can range from trivial, as exhibited by jotting down a phone number, to profound, as exhibited by Albert Einstein, who inferred a new theory of the universe. And the thing is that it's because it's so broad, that's why you have so many machine learning algorithms, and this is why it's so difficult to kind of say what is the definition. And this is why I couldn't really think of a definition last time, because I knew it's like so broad. So it's more like just a way of learning, of improving performance by any means possible. And today we have the way we do that is basically by reducing the gradient descent basically approach, which is that you try to reduce the error as much as possible by keep on going at that problem again and again, and try to reduce the error as by seeing how much different you are from last time, how much should it be, and then you try again and then reduce the error. And so it's basically that sort of approach that machine learning today has just been applied to everything, every single field within AI.
So would you say that I'd like to think of AI, and this is a really simple view of it, I'd like to think of AI as a thought that's come into somebody's head, a theory, an idea that has had a specific that a computer is dedicated to solving. So say, for example, we say, right, I want to figure, again, very abstract, but I want to figure out how to get to Mars, right? I know there's a whole ton of things that need to be done to get to Mars, but the actual you could program an AI to solve that problem. I mean, not right now, but in the future, you could possibly program an AI or a neural network or a series of neural networks to be able to solve all of the problems that are needed to be solved, to be able to get us to Mars or something like. It's a bit big, it's a bit large, a bit grand, that I suppose. But yeah, but
it's for AI itself.
So okay, so we can keep with the pictures of cats. That's it makes it a bit easier to grasp at the moment. But at the moment, we don't have any worries about AI taking over the world right now.
We don't have any worries, and if there was an issue, what I would say is that it would be because we programmed it. The AI is going to become clever because we programmed it, not because it is clever. It is all depending on us, on how we give it the conscious or whatever it has. The whole brain is what we give it and how we tell it how it thinks. And it's how it thinks all these steps is something we have to program, and simply can't do anything in itself unless we tell it how it needs to do what itself.
Well, when we get to the subject, we talked about it last time briefly about general AI, and we talk about AI that can write code that teaches it more. Teaches.
It's basically too far, because we have to tell
science fiction at the moment.
Yeah, we have to tell it. Even that, we have to tell it how it has to be done.
Yeah. So what I'm saying is, it would be. I'm assuming if we ever did get to that point where an AI could write its own code or its own algorithms to learn other things, not necessarily what it's been specialized in, other things related to it, at that point it would be a split second before, because computers would be so powerful by that point that if that happened and it could write its own things, it would write everything, and it would suddenly be the most powerful and intelligent thing on the planet.
But I don't know. From what I understand, it seems like we have to give a lot of information. We have to give not only data, and we also have to give in how it needs to process and think. It's just not. I can't see the feature where it will all of a sudden it will start doing everything itself. That is just. It sounds too good to be true, because it's the way, when you program it and when you see errors and when you're trying to do so much research is going into, as in so much conscious human brain power, conscious meaningful brain power is going into programming this, and still it's not good enough. And then you're thinking, it'll become all powerful in itself. It's just not. It does not happen like that.
Don't get me wrong. It's a thought experiment. I'm not worried for 1 second. It's just interesting to think about the scenario where if a computer, if a program, if an AI, if a neural network, if anything that was programmed by humans was powerful enough to write its own algorithms, to allow it to learn, just think about what that would take to get to that point. It's insane. Then at that point, at the split second it was able to do that, it would just suddenly know everything, because it would be able to very quickly write. It would be able to answer all of the questions of the universe immediately, because it knows, and it's pie in the sky. It's complete madness to think that we could even get to that point. But it's nice. It's nice to watch films like Deus Ex Machina or Ex Machina rather, and Terminator and those kind of things where the AIs have taken over, and it's like, oh, this is going to be our future. But I genuinely think we'll destroy ourselves before the AIs are even close to being capable of that. Anyway, let us close the show. Thank you very much, Zain. It has been wonderful having you on the show. Thanks to everybody in Twitch chat. There has been a few comments during the show, but most people have been quiet and respectful, like me, during the show, because it's always interesting getting people on who know a lot about things that I don't know, because I find myself fascinated by it. My mind, as you probably noticed, my mind goes a bit crazy, and it's like I'm trying to figure out how I could use it in my existing kind of world. Where would I be able to apply this, apart from, writing things that have already, or playing around with things that are just random ideas, but then also how it is being used in the wider world. And there's all kinds of things going on that I've got no idea about, because I'm not on the cutting edge, and I don't read all the newspapers, and I don't read all the technical articles out there. And there's all kinds of things that AI is being used for that we just don't know, and we are feeding data to it constantly as well. So yes, thank you, Zain. Is now your time to pimp yourself if you've got any side projects you're in the middle of, or you've got a company you want to advertise, or just anything cool that you've got to share?
Sure. So I'm basically a data strategy consultant, and what I do is I help companies create a data strategy and show how it can be implemented, whether it requires AI or whether it doesn't require AI, and what it means to how we can actually make money using data, or save money first, actually save money and then make money. So that's what I normally do. So yeah.
Good stuff. Well, Sid, thanks for having you. It's been wonderful. Thanks for coming on. You can visit our website on www.DNIStream.live, where we have all of our podcasts, past and this one will be on very shortly in the future. All our social media channels are on there, and you can join our Discord server from there too. You can also use it to get in touch with us for anything. If you want to be a guest on the show, you've got any topics you want us to talk about, or you've got any feedback or anything like that, or you want to get in touch with Zane. And you've got his Twitter and his LinkedIn right there anyway. So please do if that's your thing. And don't forget to follow our Twitch channel. We are now Twitch affiliates as well. We've finally turned it on. So if you really do want to subscribe, there is a button at the top. We're not the kind of people who'll scream about it. So probably the first and last time I'll say anything about it, at least anyway. We hope to see you all next week at 7 p.m. on Thursday. Hopefully Josie will be back with us, but if she has got the dreaded C word, then maybe she won't be with us. Maybe she'll be off for a few weeks. But yes, much love to Josie, and I'm sure everybody in chat says the same. And thank you very much, Zane.
Thank you.
See you all next week.
See you. Bye.